Hello again, we're on page 4 and we're in chapter 9.4, adding and subtracting radicals. And just like terms, you have to have like radicals to be able to add or subtract. And by like radicals, we mean the index needs to be the same and the radicand, whatever's under the bracket, has to be the same. Looking at a few examples. What's the 5 and the 7 there? Those are just coefficients, really. You could think of them as coefficients. 5 of these, 7 of these. Are these the same? Let's see. They have the same index, 3, and they have the same radicand, 11. So these are like. Here the coefficients are 3 and 5. They're both square roots, but the radicands are different. This is square root 2, square root 3. These are unlike. Let's write that down. These are like, and these are unlike. Doesn't mean they're bad, they're just unlike. And again, what's the 4 and the 11? They're coefficients. They're both cube roots. That checks out. And then comparing the radicand, it's x to the first, y to the second. Perfect match. These are like. Look at the next one. The 4 and the 11, those are outside. Those are coefficients. We don't need those to be the same. The indexes, immediately we see the indexes are different. Even though the radicand is the same, x, y squared in both, the indexes are different, so we have unlike radicals. We'll just write unlike there in my best handwriting. And finally, 6 of these, 3 of these, are they the same? Yes, they're both square roots and they're both 7s, so they're both square root 7s. So these are another pair of like radicals. So if they are like, we can add or subtract. And just like we did with variables, plain old variables earlier in the semester, we work with the coefficients. 3 of these things plus 5 of these things means we have 8 of these things. And by these things, I mean square root x's. Slide over here. Are these like? It's 7 root 15s minus 2 root 15s. They're both square roots of 15s. So 7 of them, take away 2 of them. We have 5 square root 15s. Now don't get fooled by this. Don't let your brain double cross you. This is a square root 5 plus another square root 5. We could, if we wanted to force the issue, put in a coefficient of 1 on both of them. 1 of those plus 1 of those, we have 2 of those. We have 2 square root 5s. Just like x plus x would be 2x. Square root 5 plus square root 5 would be 2 square root 5s. Don't fall for this. Square root 2 plus square root 2 does not equal the square root of 4. Square root 2 plus square root 2 equals 2 times the square root of 2. Remember, square root of 2, if you put that in the calculator, is approximately 1.4. And if you add 1.4 plus 1.4, you get 2.8. This is exactly 2. See that they're not the same thing? Okay. Moving down here, 3 terms. 5 of these plus 7 of these minus 4 of these, if they're the same. Are they the same? They're all 3 of them cube roots, and the radicands are all the same, PW. So these, it's just like 5x plus 7x, take away 4x. We would combine those. So 5 plus 7 is 12. Take away 4 gives us a grand total of 8 of these. Now very carefully, I want to write this. Don't want to make it look like 8 to the 3rd power. No, no, no. It's 8 cube root of PW. Okay? 8 8. That's how many times I've washed my hands probably in the past hour. No fooling, because I went out to get the mail and I'm scared to death of the mail. This is a little more elusive. It's square root, it's 2w, it's 2w. Now what about the x? We're going to count this, or we're going to look at this way. The like term here, the like terms are 6 of what, 11 of what? X square root 2w. There's another x square root 2w. 6 of them added to 11 of them gives us 17 of them. 17 x square root 2w's. That takes a little getting used to, but that's what it simplifies into. Okay? Now this is not a FOIL problem. There's a subtract sign in the middle. It's this expression. Take away this expression, and we got different kinds of terms here. We have to look very, very carefully. Got root 3's and root 3's and cube root 3's and cube root 3's. So let me rewrite this. Let me slow it down a little bit. I'm going to write 7 root 3 and then minus, taking away 2 root 3's, and we've got the plus 4 cube root 3. And over here, it's take away negative. Take away negative becomes add the opposite. So that's add 10 cube root 3's. So 7 of these, take away 2 of these. We've got 5 square root 3's, and then plus 4 of these plus 10 of these, 14 cube root 3's. Hope that's okay. And the last item on page 4, is this subtraction doable? It's 12 of something minus 8 of something. Are they the same something? They're both cube roots. The radicands match x squared y. So we can change this to 12 take away 8 is 4. So it's 4 cube root. Notice the careful arrangement of where the index goes. Cube root x squared y. That's the end of page 4. Thanks for watching. Page 5 coming soon.